Today, I'm really excited to have Ido Halevi on the podcast. Ido is an industry leader in product management. He is currently director of product for Datagen, a startup that is providing high performance synthetic data with a focus on human centric computer vision applications. Prior to Datagen, he had started his career as an engineer at Intel before moving to product management roles at logs.io. He later moved to become a senior PM at Explorium before finally joining Datagen. Outside of work, he is also a mentor at ScaleUp, an organization that is focused on creating innovative solutions and initiatives for human capital challenges in the high-tech ecosystem. And he's also a mentor at Max Initiative, which is an educational impact entrepreneurship program. Having Ido on the podcast was great because beyond talking about his product building experience, it was great to talk to somebody who's working on a field in AI that I don't think is talked about enough. The fact that using synthetic data or data created by an AI model to train another AI model is actually getting better than using a real life data training set is sort of mind blowing to me. And it was really great to talk to somebody who's in the weeds with it. With that said, I hope you enjoy the podcast. Hello, Ido, and welcome to the podcast.
Very nice to meet you.
Yeah, great to have you on, and I'm super excited to get into DataGen. It's a really exciting product, and I'm really excited to get dive into it. But before we get started, I wanted to find out what brought you to the world of product management. What brought you towards this product?
It was actually by a mistake. I never intended to be a product manager when I finished my college degree. I studied
Mm,
engineering, computer science, and electronic engineering, and I started as an engineer working for Intel. After a couple of years, I just understood that I don't like writing code, but I do like complex systems.
mm,
And I'm much more attracted to the business aspect of building a product than towards the technology side. So that's basically what led me to product management, where I'm focusing mostly on B2B, or what like we could like to call it B2D, business to developers,
mm.
and products where the products themselves are very, very technical. Yeah, and that's it.
No, I mean that's a super fair story. I mean, I feel like it's a lot of people get into product management. That's sort of a natural progression where they start off on the technical, they realize that hey, like in my case, for example, like I enjoy the technical, but I feel like I'm missing something here in my job. And so I naturally started gravitating toward product management, and I haven't really looked back since.
Yeah.
So that's sort of like the classic story there.
Yes,
Um,
definitely.
and then sort of you sort of mentioned this where you started off your career at Intel before jumping into smaller organizations. So I was just wondering in general, like what have you done to decide on what to pursue next? Like what is your guiding principles there?
Yeah. So I'm not sure if it's normal or not, or if other people think the way I did, but at each move I try to see what I'm missing and what I can learn for my next step. And
Mhm.
so I started in a very big company working as an engineer, and then I just wanted to land my first PM job, right? I didn't
Right.
care much. I had like boundaries of where I want to be. Like I told you, a B2B and technical product, but it didn't really matter to me whether it was like a security, fintech, or the domain itself, the industry. Um, After my first job, I just searched for things that I felt like missing, like whether it's a smaller company or a specific domain like machine learning. And for machine learning, I moved to computer vision and so on and so forth. So with each move, I opt for the learning and the experience rather
Mhm.
than the salary, if I have to say. Like actually, I dropped my salary with each move instead of increasing it. I dropped it, and eventually it catched up, right? Like after a year or two, it catched up to even higher than what I had before. But yeah.
Right, that makes a lot of sense, and I think, yeah, I think too many people optimize for their salary, and they don't think enough about the learning experience and the skill that they'll gain to bring value. And I think in general we can get caught up. I feel like get caught up in this loop of just trying to just go up the salary ranks as soon as possible, but we don't necessarily think about how that's going to benefit us in the long term.
Yeah,
And I can speak, especially being young, of course, money is on my mind, but I'm trying to also find strike a balance there.
yeah. Look,
So yes, sir.
salary is important. It's just how would I say it? It's like um, I had faith that it will catch up
Right,
eventually if I'll be good enough.
right.
And I always felt like because I wanted to compensate or not compensate, learn stuff that I felt missing. So
Mm-hmm.
I always felt like I was junior when I started fresh. So I felt like it's fine. This is my time to um, like not focusing on the money aspect and just
Right.
focusing on the experience, believing that it will pay off years later with dividends.
For sure. And I mean, I think you're also in such a unique place as well because, the Israeli tech scene, I think, has, of course, has always been there, but I think especially in the last 10 years, specifically in machine learning and artificial intelligence, but general software as well, it's just completely exploded.
Yeah.
And it's crazy to me. I really think I am hard pressed to find a more advanced tech sector in machine learning and AI, but in other areas as well than is in Israel nowadays.
Yeah. So we were
It's
always
crazy.
definitely, and we were always strong in security domain.
Yep.
I guess it's obvious because most of us served in the army, in the intelligence force, and so on and so forth. So you get that expertise and the knowledge.
Hmm.
But other sectors are catching up. I mean, we have a lot of companies that are working for developers, a lot of companies in fintech. And
Hmm.
when blockchain was like at the hype, I saw a few like a lot of companies on the blockchain domain.
Right.
So yeah, it's mostly the culture here. People want to be entrepreneurs, and they
Right.
have you say the courage or the chutzpah in Hebrew
Right.
for just going after it. And with the economy that we had, where money was non-issue and funding was, I don't want to say easy, but easier than it is today.
Hmm.
Um, it really pushed forward the tech industry in Israel.
For sure. No, and I'm super excited to see what comes up in Israel. So let's talk about one of the most exciting startups I feel like in Israel, which is Datagen. And of course, you
Okay.
guys have offices in New York, Israel, so you are a global company, but you do have a large presence in Israel. And just to give some context to our viewers, if you haven't heard of Datagen before, Datagen is essentially a platform that allows you to write your own code to test and train your models by generating the exact synthetic data that you need. And so I'll throw some links in the bio. And Datagen's hiring a lot right now, so definitely, if you guys are interested in the MLAI space, it's a super interesting company to get into, and I think it's one of those, like based on my own experiences, I think it's one of those sleeper companies, which is really rumbling in the background because you guys have so much potential and so many clients that you're also onboarding. So I think especially in the next 2 or 3 years, everybody will get to know in the space. Will get to know about Datagen. But if you want to join early on, well, it's still in the more discovery phase, I guess. This is a
Yeah.
good time.
Yes, definitely. And if people want to contact me personally, it's also fine. I mean, I would love to answer any question that you guys have.
For sure, yeah, and I'll leave all of Ido's direct links in the bio as well. So, but let's talk about it. So I think in general, with AI models, your model can only be as good as the data you have to train it. And it's the reason why so many different companies invest millions and sometimes even billions of dollars in sourcing data sets in order to train their models, and or annotating data to feed into the different models. And so when you look at the data sourcing and annotation space today, where do you think DataGen fits into this picture,
Yeah.
and what is their unique value proposition here?
Yeah. So maybe before that, it's very important to understand like a few steps back and
Hmm.
understand who are we building it for, right? So usually our customers are computer vision engineer, and what's special about computer vision engineer is that they're in some kind of a experiment most of the time too, right? It's the industry or their implementations are still not set in stone like regular software, if I might
Right.
say so. So um, our customers are experimenting. They don't really know what will work, or they have a guess of what will work and what will not work. And now they need to test it, iterate, and so on and so forth without really know how it's going to impact their model. Okay. And the problem that we are solving for them is just like you said, it's how to acquire the right data. So
Right.
if you think about it, um, up till now, uh, most of the engineers were iterating on the model, right? Where you try to boost your performance, you would iterate on the model, playing with the weights, playing with everything else that you have there, and so on and so forth. But the way that we like to think about it is almost like a pyramid, where the base layer is the data. That
Right.
what's going to give you the most boost to your performance, and the more robust, heavy, wide that it will be, the better the model will be. Because it's like you said, it can only be as good as your model can be only as good as your data. Now,
Mm-hmm.
the way engineers did it so far, the common way, was with real data, right? When you think about it, if I want to detect this pen that I have here, right? I'm going to try to simplify it very much for people that are not from the domain, right? But it's very much like a baby brain. You're going to
Mm-hmm.
tell him, this is a pen, this is a pen, this is a pen. I'm going to twist the pen and keep saying, this is a pen. I will show the baby the pen during the night, during the day, behind my hand, sorry,
Right.
occluded with many, many things. The next time that the baby will see the pen, with high chances, it will say, this is a pen, right? And the same with the models. You feed it with pictures and everything and the annotation saying that this is a pen. So the model can learn to predict whether it's a pen or not. But when I'll show him this thing, right? It's a pencil. Both of them are blue. But this one is a pencil and this one is a pen.
Right.
It will be hard to the baby to say this is a pencil because the baby never learned that what is a pencil, right? It can only say
Right.
that this is a pen. The chances that this is a pen is 20%. I don't know, right? Um, and so far, the way that we trained model was acquiring a lot of images or going out and take them by yourself or by a third party, and then sending them to an annotation company or annotate them themselves with all the information so that the model can get the images and the information on that image and learn from it. Okay. Instead, with synthetic data, what are we doing? Is that do you remember the game The Sims? I don't know if
Mm-hmm.
everyone played it, right? So basically, what we are trying to do, or what we are doing, is building a snapshot of the world in 3D dimension.
Okay.
Okay. So if I'll take the entire world and I'll be able to model it in 3D and then locate the camera wherever I want within that environment, I can get all the variants that the world encapsulate
Right.
and train the best model that I need with all the information. Okay. So
Right.
what we do is we simulate the world and then we empower computer vision engineers and give them the tools to do everything on their own instead of going on this long and tedious production to acquire the data. So instead of doing all the hard and long work that some of it is not on their, like they don't control it, now with the click of a button or with a call to one of our API endpoints, you can basically construct whatever scene you want as long as it's focused on human, because we are a company that focused on human-centric synthetic data, and to get the exact data that you ask for. Okay, and the
Right.
concept itself is very powerful because if you remember, we talked with this tool. Basically, what you can do is iterate much easily on the data area instead of the model area because data is at a click of a button from your hand, right? So
Mm-hmm.
we basically empower computer vision engineer to have an end-to-end control of everything regarding the data they need to train and test their computer vision models.
Right. Right. Wow. That's Yeah, I mean, it's a concept where, especially when I was prepping for the podcast, I had to brush up my books and think about, okay, do a quick refresher of machine learning. But no, it's such an interesting concept because, for the longest time, even the way I've learned, it's just, training based on annotated data. And so to have a concept where you can have synthetic data from like it's artificially generated data training new AI models.
Yeah,
It's sort of, it sort of blows your mind a little bit that it's
yeah.
impossible, but it makes a lot of sense.
And
uh
the beautiful thing about it is, um, because we have all the 3D assets in order to simulate the world, we also have all the information on those assets. So
right.
all the annotations you get for, I want to say for free, but I mean with less effort, with none effort at all, right? You don't
Hmm.
need to do another step of annotating the images. Plus, because we are working in a 3D dimension instead of working in like in real world when you take images that's 2D, you get a lot of extra information that you don't have in the
Right.
real world. Um, for example, uh, it's really hard to annotate the gaze vector of the eyes, right?
Right.
Now, if you want to do like a gaze detection algorithm to make sure that I don't know, the driver of in your car always looks on the road and not on the phone, then this is something that you can do mostly with synthetic data because we control the eyes. We have a perfectly um, accurate eye model that is accurate to the real world. So we know that the vector is also correct. And
Right.
because we have all the information behind the scenes and all the assets, we can provide the vector itself and not just assume or predict or guess where the person is looking at. Same with simple annotations like key point, you can get them in 3D or in 2D, like in the image space or in world coordinates. So
Right.
it gives another layer of information that you couldn't do with real images. And it shows a lot of differences. Like when we started with the key points, so there are like specific formats for face key point. Okay.
Hmm.
Now in real life, if I look to the side and there is a key point here, so I'm not sure everyone is looking at a video. Probably someone is just
Right.
listening. So if I have a key point near the ear, and now I turn my head in a way that the ear is covered, it's really hard to annotate that key point because it's not visible,
Right.
right? So what we saw is that in real life, what they usually do is that they take this key point and put it somewhere on the nose, on the line, on the edges of the face that is visible.
Right.
So you have like inconsistent annotations just because that's what's possible. But
Hmm.
because we actually control the 3D model of the head, we can give both. We can give the real key point, plus telling you it's not visible from that camera angle,
Right.
and also give you the key point that is the closest to the visible part on the face.
Right. No, that's I mean, from that perspective, right? You're innovating both. I mean, of course, generating synthetic data is going to be cheaper than annotation in the long run. It's more high quality data in terms of the annotations that you guys can generate because of that. So like, what like what am I missing here? I think that's the future, right? There's a like, why else would you like? I guess like, why else would you source data otherwise?
Yeah, so it's not an easy job. So it sounds
Okay.
very simple because we all played games where you see humans and you see environments and you see,
Right.
I don't know, glasses and whatever. But the real challenge with simulating the data that we try to simulate, which is human-centric data, in context with everything that humans interact and do in real life, is how do you keep it true to
Yeah.
what happens in real life. So one example is how do we make sure, like, what is a human? That's a good like that's an example I always like to use when I'm interviewing people, just to share how difficult and interesting the problems that we are solving. So in real life, right, you have an ID, maybe a DNA that you can take, the name that your parents give you, some witnesses that say this is Ido, right? But when everything is synthetic, you now need to take this challenge of what is a human and turn it into a mathematical equation. So
Yeah.
you can distinguish between two people. Now, there are tough questions. Is Ido's hair is part of Ido's identity?
Right.
I don't know. Are the eyebrows, if I have a scar, is it part of the identity? If now I break my nose and the geometry of my nose changes, is
Mm-hmm.
it still Ido?
Right.
So, for example, those are tough questions. But if I go back to your question, how do we source data? So the number one rule that you are trying to keep is we need to make sure that the data performs just as good as real data, if not
Right.
better. And the way to do it is to stay true to how reality works, right? So, for example, in order to build our human, we have a 3D scans of real people where we use them to create those avatars that we provide our customers. So that will keep the geometry and the texture and everything that human encapsulate. One of the coolest things that we do is that when we simulate motion, for example, we actually record it from the reality. We've built an in-house studio with like
Mm-hmm.
a Hollywood production mock-up, gadgets and technology, and we have actors that are coming and performing the motions that we need, and then we take those motions, we clean them up and everything, but and we apply them to our synthetic humans. This
Right.
is really really important because, like I said, we want to be as true as possible and the data to be as quality, uh, the best data that we can provide, and that means that it needs to be derived from the real world somehow, and that's a really really tough thing to do.
Right. And that's what I was sort of I was actually going to lead into that. I think one of the things with synthetic data, like I alluded to earlier, is that it's models, it's AI models generating data from AI models. And so, just like how important the training data set is for the models downstream, of course, the upstream models also need a very selected and high quality data set. And so I was just wondering, and you sort of touched on this, but how does data gen go about sourcing its data sets for its own models that generate that data?
Yeah. So like I said, we scan people, we record motion, and we make sure that everything that we do is sourced from reality. And then we
Mm-hmm.
have very complex pipelines and models, algorithm models that we use in-house together with those inputs from the real world in order to provide the synthetic output that we provide to our customers. Okay.
Right.
Um, yeah. Now, okay, sorry, go ahead.
Oh yeah. Yeah. So and I think when you touched on this as well, right? So there's different features that humans will have and different environments will have, and I think not only finding those features is so important, but assigning weights to those features are also so important. And like you touched on, like with humans, what are the highest differentiating factors that you want to point out, and you want to make sure is in your synthetic data as a way to differentiate different data you're generating. So when it comes to designing some of your neural nets there, and trying to find those features, like what are some of the considerations there that DataGen has?
Yeah. So we focus on the data itself and not the model. So the goal that we have is, like I said in the beginning, to empower our customers to control every dimension of this synthetic world that we provide. And by
Mm-hmm.
controlling every dimension of this synthetic world, they basically can do customize however they want the data, and play later on with the weights on the model side, making sure that everything works and that they don't have biases and so on and so forth. And for example, if you want to control the hair color, we won't just give you blonde, black, brown, goldish, whatever it is. We're going to try to be as similar as to the real world. So we'll give you melanin. We'll give you like a whiteness parameter that you can play with. Now
Right.
you can take the same character and just change the colors of the hair, right? So now you have Ido in different points in time if I ever wanted to paint my hair. Um, and this is something that is very, very, very powerful. Our clients eventually are super smart. The technology that they are building is extremely complex,
Right.
and our job is to make their work much, much easier in everything related to the data aspect of the model.
Right, for sure. And I think, you touched on the engineers being able to control the different dimensions within the data. So you can, if there's a specific case they want to optimize for, they can do that.
Mhm.
Which is, of course, something I think that synthetic data, it's one of the benefits there. Because in real life data, you can try sourcing certain data types, but you really have to have a large training set for that. And most of the time, it'll be a very small subsection that you're able to do that
Definitely.
for.
Yeah.
So I think that's a huge advantage for synthetic data. But I think with that, so you mentioned that you have these dimensions that you want to let your customers choose. So I was just wondering, like, when it comes to choosing what dimensions those are, because of course, at the end of the day, you have to offer that to the customer on your platform. How do you first, how do you determine what those are? And second, how do you make sure that your initial training set that you're going to be feeding into these models have enough data that people can manipulate it on your platform later on?
Yeah. Um, so it's a tough question, by the way. Not because I don't know how to answer, because once we answer it per dimension, it takes time to define those things.
Right.
Um, but in general, um, eventually, like I said, we want to simulate the world, right? So when you think about a single dimension or some of those dimensions, for example, expressions, right?
Hmm.
Expressions of the face. Um, we when we design the product or the feature or the control, we try to think how to design it in a way that will bring the most variance, right? Or
Hmm.
variance that will encapsulate everything that you can see in the world so that models can train and then on synthetic data and then infer on real data without a problem. We try to think of ease of use, of course, right? So
Hmm.
sometimes we need maybe abstractions on top of that because not everyone knows how to what melanin means. If I'll take my previous example,
Right.
maybe they just want black, brown, or brown one, brown two, brown three, right?
Yeah.
Um, and the way that we and what we also do is that we have many benchmarks internally before we release something. So we
Hmm.
have like state of the art benchmark for facial recognition and segmentation and so on and so forth, and to guarantee that our data actually performs as we say it is, we first check it in house. So on top of everything that we are investing on, like physics-based simulation, recording the motion, making sure the eye model is accurate, and so on and so forth, which is on itself is a very, very challenging work. We also, after we do all those things, we also benchmark each area of the data, each dimension, and
Right.
making sure that it actually contributes. Because eventually, the goal of our customers is to train on synthetic data and then infer on real data, and making sure that it actually works on real data, not on synthetic data, right?
Right. Right. No,
And
and I think no, that's super interesting. And yeah, I don't want to see your guys' data center bill, but I'm sure the amount of GPU resources you guys are using, it's pretty high.
yeah, yeah, definitely. And it's also one of the challenges of building a product like Datagen, right? We are all very accustomed to like be focused on like the infrastructure is usually built on CPUs in
Mm-hmm.
regular products, where the cost is linear to the number of machines, sometimes even less than linear.
Right.
Uh, when it's GPU sensitive, then you're correct. There is another challenge building the product, and cost is not something that you can just forget about and give it to the engineers. Almost every decision comes with a cost, literally a cost,
Yeah.
to the infrastructure, which also changes a bit the equation for the finance team and so on and so forth. So the product team here is it's a very complex product to build.
Right. No, that makes sense. And I think, in the software world, especially right now, everybody always talks about bootstrapping and not really needing that much capital to get things started, which I think rings true to some degree. But when you have, AI platforms and you're actually trying to develop your own AI platform,
Yeah,
I think that's one of the few areas in software, even now, that it does require capital and then an investment to
definitely.
get to that point.
Yeah, probably it will advance as well, right? It's just a matter of time. But for now, it's not that easy.
For sure. Yeah. Well, hopefully GPU costs go down and you guys can increase your margins even more so. I'm sure it will. But yeah, no, I mean, I don't mean to make this a rapid fire round going over and over, but it's just super interesting. And I think, one of the things you talked about there was the evaluation of the models. So, you mentioned that you have some certain facial recognition software and different ways of evaluating the models. And I think, when I think about it, in a conventional ML model where you can look at statistics like sensitivity, specificity, specificity, and generalizability. So it's easier to evaluate if your model's overfitting, underfitting, or is where you want it to be. I feel like that's a lot harder to do in something like, again, a generative adversarial network. And so, like, how do you guys go about evaluating your models to know that, hey, that this is producing the data that we want it for our clients?
Yeah. So, like I said, we don't provide the models themselves. We provide the data, right? So
Right.
and the way that we create the data is using a simulation and not entirely just GANs, which is much more accurate to our customers' needs. Now, to evaluate it, we also need to we kind of need to mimic our customers' work to
Right.
make sure that everything works as properly as we want it to be. So we have like a team of algo engineers which are very, very, very good at what they do,
Yeah.
um, and it's part of the steps that we take before we provide something to our customers. So we actually build some of the models in-house, right? We
Mm,
don't provide them, but we build them almost as a QA infrastructure for the data that we give customers, right? So if you think about it, we release a new feature, a new dimension, a new kind of data. It can also be like a new type of annotation, and then we give these great smart people uh, the freedom to see and test and work with this new capability and check if it actually moves the needle, right?
right.
Sometimes, unfortunately, it doesn't, and then we don't provide it to customers, or we provide it with knowing that, but just for the variance and for the look, because we have other dimensions um, just than the performance of the model for
Mm,
customers. They also want like to see that the data looks real, right? So sometimes you just need more backgrounds because I don't know, someone wants background with mountains or something
right.
like that, even though it doesn't impact so much the model performance. Um, but mostly what we're focusing on is making sure that the data we provide actually boost the performance on the model. And for that, we do a lot of testing in-house and benchmark that are very, very close to the state of the art of what you see in the industry. And
Right.
this way, we know what if what we are building actually improves the model, or at least it's a good proxy for before we provide the new capability to our customers.
Right. No, that makes sense, and I think it's such an important aspect there, right? Where it's it you can train them all a certain way. You can hope and hope it goes a certain way, but unless you have that evaluation criteria, you'll
Yeah.
never really know if it's satisfying those needs. So it becomes very important to have a not only have a smart group of people leading the actual model, creation of the model, but to also have a smart group of people evaluating the model. And I think in some, in traditional software, the role of the QA is very much disputed in terms of the importance or how how much involvement they need to have. But I
Hmm.
think especially in the AI and ML field, the role of a QA or the role of the testing teams in particular is as important
Yeah.
as the role of the creators.
Yeah, it's true, and it's also not that clear who should test it, right? Like testing is usually a job of a QA engineer.
Mm-hmm.
We're used to that developers sometimes write software. Engineers sometimes test their own. They usually test their own code to a certain degree, right? But um, with when everything is um, for models, it's a bit tricky. Like, should the software that developed the control test it? Should the QA test it? Will the innovation team, where they actually understand and know the end user the best, should they test if it impact the model? So
Right.
it's another challenge that, yeah, I think we do very very well, given that we have the right people and they are super super smart. It's like when you go into a Datagen meeting, it's almost like you feel the stupidest person in the room, um, and it really really helps giving a quality product to our customers.
For sure. No, clearly. And I mean, coming into this podcast, I definitely wanted to make sure I have some understanding going in. So I read the dust off the books there because, you guys are definitely very super talented. And the last thing I need is to fall flat on my face while I'm asking
Yeah.
questions. So I can definitely relate to that. And I think, on a tangential note, but related note, I think that's also one of the things that differentiates AI startups. We sort of touched a little bit on the capital part there, where it's a little bit more capital intensive than traditional software startups. But I think also one of the bigger moats that a startup AI ML startup has is that talent pool, and it's so important to make sure that you really have very smart people, very capable people working on these products. And it's one of the reason why whether you look at responsibility, whether you look at salary, or you look at respect throughout the industry, all
Yeah.
three of those are typically there at AI and ML companies. So this is,
Yeah.
this is an interesting point I was thinking about.
Yeah. So yeah, it's true. The way I like to define Datagen is like, if we had a Venn diagram, but just with two circles, not the common three one, the regular three circles. So you have AI on one, and then you have computer graphics on the other. So we
Mm-hmm.
are kind of the middle, because we need to understand in graphics, in computer graphics, which is also a very very intense
Yep.
algorithmical industry and domain.
Yep.
But we are somewhere in the middle, what we are building. So yeah, I'm super excited about the domain and the product itself.
For sure. And I'll say it again. If somebody's interested in being in the intersection of computer graphics, AI and ML, and working with some of the smartest people, please feel free to go check out some of the occupations that Datagen is hiring for right now. So, but
Yeah,
yeah, no, talking about synthetic data once again. So we touched on how the cost is low for synthetic data, and the ability for engineers to play around different parameters is also there in synthetic data, which definitely in the long run I feel like has a lot of benefits compared to real world data. And I think one of the interesting ones that I was like, I never really thought about, but as I'm doing more research, I'm like, oh, this is actually very interesting. Is bias as well,
hmm,
and and it's if you like you don't really think about it typically about where your data set is coming from, but I feel like a lot of data sets are for more um, are from more or less the same locations over and over again. Like you'll have maybe your New York City for cities,
Yeah,
or you might have for desert like the Sahara Desert or something. Like what I'm trying to say is like it's very I think it's very fragmented out. But of course, the world is huge, and you have so many different areas that you want to account for, and so many different combinations that you want to account for, but you don't necessarily get that in your data set. So
yeah.
I just wanted to quickly touch on that. Like that bias part is something that I didn't really necessarily think about before, but I think it's so important, especially as you're training models that are going to be used globally, which I think most AI companies are doing nowadays.
Yeah. So the cool thing, at least in my opinion, is that there are many, many advantages to synthetic data, right? So for one, like first, there are no privacy issues at all because the data is fully synthetic, right?
Mhm.
So there is no Ido data.
That's huge.
We might have someone that looks like Ido because, like I said before, we want to be as close as possible to the real world, but it's not going to be Ido. It's not going to be like a private images from Ido's photo gallery, right?
Right.
So that's one. Like you said, there are no biases, but that's because the way we solve it is that we give the users the central control to control the biases in the data. So if they want a biased data, they can get it. If they want an unbiased data, that they can also get it. It really depends on their application, right? They can select the age group, the gender group, the ethnicity group of the identities that they have in the data that we generate. Now we
Right.
talked about cost. Um, that of course it's much less than acquiring real data, right? Plus, you get all the annotation um, out of the box instead of segmented into two phases. Um, and also, the interesting part is that on top of all those advantages, it's much faster. So if you think about acquiring real data, we heard from customers, it's like a movie production. It can take 8 months to get all the people, all the actors in all different lighting condition, doing
Yeah.
all the different motions, capturing it from different cameras, different resolutions, and so on and so forth. So the time saving is huge. Now, the last thing is scalability, right? So um, instead of going on production and get maybe 10K images or trying to filter out uh, the images from a bunch of captured images that you just took, um, you can generate as many data points as we want. So we have customers generate up to, for example, 5 million data points with 50,000 synthetic paper, which means that
Mm.
you have a lot of variance on each one of them, just in order to train facial recognition algorithms, right? So together, and that's why we like calling it empowering the computer vision engineer. Together, it's a very compelling offering to our customers.
Right, for sure. And I think I know I've quizzed you like you're a data scientist, but you're actually a director of product management.
Yeah,
So I think as a product, even from a product management point of view, not only a data science point of view, it's such an interesting problem there, because you have these more specific use cases that you want to offer your customers and their ability to generate data for it. But at the same time, you want to make sure that your platform is still general enough to be used, across scenarios.
yeah,
So I think it's really exciting to think about the future of Datagen's platform, and it's really interesting in that regard. And so, like, I was just wondering, from a product management point of view now, especially given that Datagen's a self-serve platform, like, how do you find a way of keeping the the model and just the platform in general uh, usable on a general basis while still being able to cater towards specific use cases?
yeah. So the way we go after it is, and sorry, I'm gonna try to dumb it down because it can be very, very technical. So I'm gonna try and use analogy that is simpler, right?
Right.
Um, so, for example, we can take Lego, right? The game. You basically you have pieces of, I don't know how to call it, blocks, right?
Mhm.
and you can build different types of buildings, of things, structures from the same blocks, right?
Right.
uh, just by assembling them differently. And this is something that we're trying to strive for in Datagen. The way we do it is that we have many, many catalogs. So, for example, we have an identity catalog, and we have an hair catalog, and we have a clothing catalog, an environment catalog, and inside the environment we have chair catalogs and desks and animations catalog, right? And the power the powerful thing that we provide is taking all those catalogs, all those different types of Lego blocks, right? And allowing the customers to build different structures and different scenes according to what they want.
Mm-hmm.
Okay. And by doing so, we get to a very generic way of constructing a 3D scene and providing the customers the right data that they ask for. Okay.
Mm-hmm.
So, for example, a chair can be in a home setting. It can also be on the roof. It can also be on the street, right?
Right.
So, if we have those three environments and we know how to place a chair, and then we know how to uh, take a person and make the person sit on a chair and maybe drink water from a bottle, right? And so on and so forth. You can see how the same items can be used across different scenarios and different domains. And that's why I like the Lego analogy, right?
Right.
Basically, we build those building blocks, the data infrastructure, in order for our customers to then build the right application on top of this infrastructure and generate the data that they want. And then they can also iterate on that very, very quickly, and will give the flexibility to build almost everything that they need for their model. So
Right.
I hope it was clear. Yeah.
For sure. And I like the name drop there. You mentioned building blocks in the middle, so I was like, without name dropping the podcast. But no, that was a great example. I think that definitely put things into perspective. Um, and yeah, it's just funny because, you're generating, if you stick with the Lego example, and I know it doesn't work one to one, but in the same
Yeah.
way, you're generating blocks in order to help generate more structures. It's just such an interesting concept there. But yeah, no, I'm super excited to see the future of data gen. I'm sure everybody's talking about everybody started talking about AI and ML, especially in generative AI. But I'm sure we're going to start going down more into the concepts as well behind it. And as synthetic data becomes more and more prevalent, outside of just a classroom, but in an application as well, I'm sure we're going to have a lot more people have a discussion on it, and data gen is going to be right there at the forefront. So thank you so much for coming on to the podcast, Ido.
Yes, it was
Before
great.
I let you go, I have two last questions I want to ask. The first one being, is there a book that you recommend us checking out?
Um, so actually, it's hard for me to admit, but I have a very uh, like a baby born,
Okay.
new baby girl. So
Congratulations.
it's yeah, she's like 5 months, so it wasn't the best time. Like I didn't have have a lot of time reading books right now. So what I did instead is just reread many of the classic ones around product right now, just to refresh
Right.
my memory. And so I would recommend for every now and then, just I know people usually read and then never go back to whatever they read and what stayed and stick. That's what they took from it. Um, what I found is that after rereading some of the books, it's like first I forgot a lot,
Yeah.
so it's interesting. And also the point in time that I'm now at, it's like different things sticks with me right now than they stick in the previous time when I read it.
For
So
sure.
just whenever books that people like to read, especially around product,
Mhm.
um, my recommendation is every now and then just read it again and see what sticks with you this time. Yeah.
It's funny, on a related note, on a completely different thing though. I recently redid my driver's test when I moved from Canada to California. They had a requirement there, and when I was rereading the book, like I know how to drive. I've been driving for a very long time, but in the same way, right? It's I can say that, but when I was rereading the book, I'm like, wait, this is a law. I didn't remember this when I was reading the book. And so the same way, like of course, at this point of your career, you know how to do product management. You're all steam ahead. You know how to drive, right? But you never know, right? Coming back to those principles and coming back to the lessons there might be something that sticks with you this time, and in the future comes in handy. So definitely, that makes a lot of sense. And
Yeah.
I'll yeah.
No, I'm saying especially if you're in a situation like me where you don't have a lot of time right now reading, it's easier even mentally to start with something, at least for me, for something in something that you already read, because I know it. I can just like I can listen to it on the audiobook if I'm not reading it in
Right.
like a faster speed, and I'm still surprised by how beneficial it is.
Yeah, well, maybe the best way of going around that so you can make time is make that your bedtime story for your 6 month talk about product principles. Of course, I'm joking, but cool. No, like I said, really enjoyed having you on the podcast. And the last question that I have are, what are the next steps for you and Datagen? What can we look forward to?
So, like I said, I think Datagen is at the edge of the technology right now. So almost everything that comes for us next is gonna be very how to say very advanced.
Hmm.
I think we'll want to go even further into the data stack and help our customers even more with data and things that they never thought of before. Especially right now, you can see every day or every week there is a new model coming out, control net, and so on and so forth. Um, so I'm very excited with what Datagen will be able to provide customers in the future around data and to really, really solve end to end the data problem that it's not going to be something that even we talk about. It's going to be just like spinning up a new CPU on AWS. It should be that easy for our
Right.
customers. So yeah.
Yeah, that sounds. I've dabbled in ML enough to know that that sounds very useful, but it sounds insane. So hopefully we can get to that point very soon, and of course, DataGen's leading the forefront. I'll say it once again, if you're interested, please check out DataGen. They are hiring even in these times. So it's definitely a great opportunity, as you can tell from the podcast. But yeah, thank you so much, Ido, once again for coming onto the
Thank you.
podcast, and for everyone listening in. Thank you so much for tuning in. Until the next episode, take care, everyone.